All right, now that we know how to tell whether or not an equation represents a function, we want to introduce what we call function notation. So let's take an equation that we know represents a function from the last video, y equals x squared, and introduce this function notation. So once we know an equation represents a function, frequently we will remove the y and replace it with this notation. Okay, so the two lines that I've written there are mathematically equivalent. They mean exactly the same thing. This notation is just another name for the variable y. And we read this f of x. And at first this looks a little confusing because usually when I use parentheses like this, I mean multiplication, right? If I did 2 parentheses 3, I would mean 2 times 3. This is not f times x. For function notation, we say f of x, not f times x. All right, why in the world would we do this? Take a perfectly good variable and replace it with 4 different symbols smushed together that kind of look like another operation. All right, it's because it's going to allow us to state some things mathematically a little bit more succinctly than we otherwise would. All right, so with y equals x squared, I could make the statement if x is equal to 5, then y is equal to 25. With function notation, I can just say f of 5 is equal to 25. So remember that I said that that f of x parentheses notation is going to take the place of the y. They mean precisely the same thing. Okay, y and f of x mean exactly the same thing. So this statement here is telling you that y is equal to 25. It just has this window that says, hey, by the way, I had to plug in 5 to get that value of 25. So the rest of this video is just us getting used to this function notation and how to use it. All right, so I'm going to give you a bunch of random functions and ask you to find f of a bunch of stuff. So this one says evaluate f of -3 for f of x equals 5x squared minus 2x plus 1. All right, so notice in the function notation, I have removed the x and I've replaced it with this -3. And that's exactly what we're going to do over on the right with the function notation. I'm going to take out every single x that I see and leave a blank space. So 5 blank squared minus, there's an x, I'm going to replace it with a blank. Okay, and everywhere there was an x, I've removed the x and we're just going to replace it with whatever is in red in that parentheses there. So I'm going to replace all the x's with -3s. Right? We're just plugging in x equals -3. And then we just do some PEMDAS to simplify. So first I'm going to handle this exponent, -3 squared is +9. -2 times -3 is +6. Plus 1. Take care of the multiplication. This is 45 plus 6 plus 1 plus 7. And that gives me 52. All right, and that just tells us f of -3 is equal to 52 when x is -3, y is equal to 52. Let's try a few more. Evaluate f of 5t for f of x equals square root of 2x minus 1. All right, again, we have replaced the x with this time a 5t. What is t? Why is it being multiplied by 5? And what is it doing in my function? I don't know. At this point, we're just getting used to this function notation. So we're just going to go with it. So we're going to do the same thing, though. We're going to come over to the function, pull out all the x's, replace them with little windows, and then we're going to plug in whatever they ask us to put in there. They wanted f of 5t, we'll give them f of 5t. Okay, everywhere there used to be an x, now there's a 5t. And any simplification we can do, we'll go ahead and do it. Let's see. 2 times 5t would give me 10t. And then that's about all we can do with this one. Can't simplify that any further. After a while, the things they start asking us to plug into functions become variations on x. So they've replaced x with -x here. But the process is going to look exactly the same. No matter what they ask you to do, just go over to the function, remove all the x's. I got one up top, and I got one on bottom. So same formula, everywhere there's an x, now there's a window, and replace it with whatever nonsense they put in the parentheses. And this time that nonsense is -x. See what you can do to simplify. Again, this one doesn't have a whole lot. 7 times -x is -7x. 5 times -x is -5x. And actually, this one, there's nothing else to do then just draw a box around it. Because of the subtraction and addition in the middle of the numerator and denominator, you can't cancel those negatives out in the front. You can't scratch out anything on top and bottom because there's addition and subtraction. All right, last one I'm going to do for you, and then I'll turn you loose on one of your own. G of x minus 3 for g of x equals absolute value of 5 minus 2x. This function is called g instead of f. We can use any letter that we want to for a function. Doesn't matter. And this one has absolute value bars in it. Let's just kind of remember absolute value tells you how far a number is away from 0. So the number 13 is 13 tick marks away from 0. So the absolute value of 13 is 13. If I plug in a negative number into an absolute value, like negative 20, okay, negative 20 is 20 tick marks away from 0. We always report distances as positive. So absolute value answers are always positive. This one has subtraction in the middle of the function, but that doesn't necessarily mean that that number 5 minus 2x is always going to be a negative number. It might be positive or negative depending upon the value of x. So we're going to leave that 5 minus 2x the way it is with the absolute value bars and just leave it inside. All right, but let's go about evaluating g of x minus 3. We replaced x with x minus 3. So I'm going to go over to g of x. Everywhere there was an x, I'm going to leave a window. And then we're going to plug in wherever there's an x, x minus 3. All right, and then simplify if you can. So I can distribute this 2. We could do that. So I've got 5 minus 2x plus 6. And then I can combine the 5 and the 6, and that's going to be about it. I can say absolute value of 11 minus 2x, or negative 2x plus 11, whatever makes you happy. And then leave it in the absolute value bars. Definitely don't change that negative into a positive. All right, so one more, and this one's for you. So f of x is equal to x squared over 7 minus x. For this function, 4 different things. Evaluate f of 4, f of 7, f of m cubed, and f of x plus 3. So just give it a try to make sure you got the hang of it, and then we'll check our answers with this when we get together in class. If you're having trouble with it, show up a little bit early during that office hour and I'll help you get through it. If not, see you in class.